The word shape comes from our definition of the word object, which is that which has shape. Very simple. That was the scientific definition that everybody missed the last 10,000 years. No textbook of physics has that definition. No textbook of physics starts with a definition of object, although you cannot do physics without an object. Okay, so that's the context. Okay, so this fellow says the following. He says, get him up here. Saying object is that which has shape is absolutely absurd. Okay, good. Object. What is an object? An unidentifiable collection of matter. And he got that from the Wikipedia. It says a physical object or physical body is a collection of matter, visible or tangible surface. That's what they're suggesting it is. That's the notion these people have. But you look up the word matter and it says any substance with mass takes up space by having volume. Okay? And but then they continue to say does not include massless particles. So that's not a matter if it's massless, such as photons or other energy phenomena or waves such as light or heat. Okay, so those are not matter. Okay, so we wonder what they are. What is light? Is it a ghost? What is the category for that? And then you look up the word substance because that's how they define matter. Matter is any substance. Substance is matter. That's how they define substance. So we have matter is substance and substance is matter. Oh, great. We learned a lot. Anything that has mass and takes up space, same thing as matter. So you can't use the word substance to define the word matter because matter and substance are synonyms. But then we have the issue of mass. What is mass? Well, it turns out nobody in the last 10,000 years defined the word mass. Here is the definition of mass that you'll find, at least in the Wikipedia. It says, intrinsic property of a body, it was traditionally believed to be related to the quantity of matter in a physical body until the discovery of the atom and particle physics. It was found that different atoms and different elementary particles, theoretically with the same amount of matter, have nonetheless different masses. So, okay, they figured out that same amount of matter, different masses. Okay, great. And it says here, mass in modern physics has multiple definitions which are conceptually distinct. So at no point did they define the word mass. They just said what it ain't. And what it ain't is the quantity of matter. Okay, so what is mass? Well, it says there, one way to distinguish conceptually between at least 7 different aspects of mass, or 7 physical notions that involve the concept of mass. Okay, so they have 7 notions of mass, and I guess they pick the one they want anytime they want to use it. So you know they have their choice there. Every experiment to date has shown these 7 values to be proportional, in some cases equal. And it says there are a number of ways mass can be measured or operationally defined. Well, we don't care about operationally defined because that's defining at the end of the presentation. We have to know in advance, before you operationally define it, what you mean by the word mass. That way we can follow your presentation. And what they want to do is they do functional or operational definitions, meaning first let's run a test, and whatever comes out of that, that's the definition of mass for today. Tomorrow we don't know. That's the way they handle it. And so the people who said it really correctly are Wheeler and Taylor here, and they said, nature does not offer us any concept as the amount of matter. History has struck down every proposal to define such a term. Even if we could count number of atoms or by any other counting method, try to evaluate amount of matter, that number would not equal mass. So what did you learn today, son, in school? Well, I learned very little, Father, because nobody can tell me what mass is. They tell me what mass ain't, not what it is. And then they say there's different kinds of masses. Okay, great. What is mass? Before you can tell us the differences between them. And they can't tell you. Of course they can't. And just in case, what was the other word? Volume. Here it is. They don't know what volume is either. Volume is a measure of 3-dimensional space. Well, I didn't know space had 3 dimensions. Space only has 0 dimensions because space is nothing. A cube has 3 dimensions, not space. But see, they always mistake these words. They call it word salad. You know, they don't like to deal with grammar, and they think that's something reserved for English majors or librarians, who knows. And it says the volume of a container is the capacity of the container. Okay, And again, it says capacity is the maximum amount of material that a container can hold. That's in one article in Wikipedia. Another one says an object that sinks displaces an amount of fluid equal to the object's volume. So we got a problem. Either volume is what's inside the container, or volume is what the container pushed aside when it was pushed inside the water. Okay, so here you have the example of a little bolt. It was thrown in water, and that's how much how much water it displaced, and that's known as volume. But these people first say that volume is the same thing as capacity, which is how much the test tube holds as far as water is concerned. So we got a problem. We don't know if volume is on the inside of the test tube or on the outside of the test tube. And they have both. They say it's both. So we don't know what mass is. We don't know what volume is, okay, because they have all these different definitions and different notions. They don't really pinpoint them. They just leave it like that, and they say, well, that's good enough, and they continue. This is the problem. Okay, so this same fellow then comes over and says, form is a three-dimensional geometric figure such as a sphere, cube, cylinder. Okay, form exists in 3 dimensions with height, width, and depth. Depth? I didn't know depth was a dimension. I mean, where does this poor fellow study? Some monastery or what? And yeah, depth is like breadth are vectors. And the only thing I want to say about breadth here is that, you know, in other languages, they don't have the word for breadth at all. You know, I found out that talking with different people, I finally came to the understanding that they don't have a word for breadth. They sometimes use amplitude. That's the closest they've got, you know, sideways, direction. But we're always, when you talk about depth, breadth, or elevation, you're talking about motion. And for this poor fellow to confuse it with a dimension, which is a static concept, whereas vector is a dynamic concept, it means, you know, that he missed important classes at the university. If he went to the university, or more than likely, you know, he got all his information from a monastery. That's probably where he studied. Okay, yeah, breadth is not a breadth or depth are not dimensions or coordinates for that matter. They're vectors. Okay, and this fellow continued. He said, shape is 2-dimensional and form is 3-dimensional, geometric figure. And the question is, where did he get this? And a lot of people have the same misconception, you know. And, you know, we look them up and find out what the definition of these words are. Okay, let's find out. It says shape, the quality of a distinct object or body in having an external surface or outline or form or figure. So they're talking about an object or a body, right? And they're just talking about the external surface or outline. Okay, so it could refer to the outline or the external surface. Surface is a 3-dimensional term. Okay, surface refers to a 3-dimensional object. Only 3-dimensional objects have surface. 2-dimensional, you know, planes and so on, they don't have surface. That's not called a surface. They're called planes. Okay, and this quality is found in some object or body, right? And it says its form. Okay, outline, silhouette. And then when you look at form, it says external appearance of a clearly defined area as distinguished from color or material, configuration, a triangular form. And it says the shape of a thing or person, something that gives or determines shape, a mold. So this notion that this fellow has that shape and form are somehow different, you know, is uncalled for, unwarranted, unjustified. He never justified that at all. Okay, and just in case, in different languages, I can only tell you the ones that I either speak or studied or am familiar with, which are the first 7 there. And, you know, in Spanish, Russian, form, German, French, Portuguese, and Italian, essentially they don't have a word shape. They use the word form for everything. There is no difference between shape and form, and as you can see from the definition, shape and form are synonyms. There is no difference between shape and form. Now, some people want to use the word shape to refer to a 2D and form to refer to 3D. That's their personal prerogative, but there's nothing in the definitions that shows that. Okay, and then you can see other languages there, the same thing. They only have the word form in almost every language. Okay, so there is no such word as shape in other languages. Okay, so they don't make a distinction between shape and form, one being 2D and the other one 3D. They just call form to everything. Okay, that's the first issue. Okay, so here you have a 3D cube. Well, is it? Looks like a 2D cube to me because it's on a flat platform, flat background. Okay, so what I'm staring at is really a 2D cube. There is no 3D. Now, it's the mind that gives projection, depth, or length, latitude, or whatever you want to call it. You have something here where you can see a projection, right? Well, but it's because the mind does that. What's coming out of the screen is not 3D. What's coming out of the screen is objectively 2D. And it's the mind that fools you into believing that you're staring at something with projection. So let's remove the stuff that's bothering you that makes you think that this is a 3D object. Here it is, okay? That's what you were staring at. Some of those lines were bothering you, okay? They were making you mistake what was coming out of screen objectively, which was 2D, for a 3D object simply because we put these lines on there, okay? So it's the mind that does that, not what's coming out of the screen. Objectively is what comes out of the screen. Subjectively is what you have in your mind, okay? And so the first thing I want to mention is that, the reason we say object is that which has shape is because even if it were 3D, even if you use form and accept it as 3D, the 3D includes the 2D. So by using the 2D shape, as you want to call it, you're including all objects in the universe. Includes anything that's 2D and 3D, and there's no 0D, 1D, or 4D or above. So by putting 2D, you include every object in the universe. Now, if you want to specify and say, well, that's a 3D object and this is a 2D object, no problem. Yeah, you can specify that later. But object, that which has shape. And shape, if it's 2D in your mind, no problem. It still covers the 3D because 3D objects have shape also. Okay, imagine here's a lady and she's trying to give a presentation and she says, and this is Schrodinger's cat before he died. Okay, and so the question here is you say, oh, you can't present that in physics because you're presenting a 2D object. That's not a 3D cat, that's a 2D cat. And so if a person gives a presentation, they are not able to say this cat is an object, is a thing. You say, no, it's not a thing because it's 2D. It has shape, but it doesn't have form. Well, obviously, you're representing a cat, and just like you did with a cube, you're supposed to imagine, right, see what's not on the screen. What's on the screen is 2D, but your mind already understands, or is supposed to understand, that that cat is 3D, okay? And the reason it's 2D only because you had to bring a picture of the cat, snapshot you took of your own cat maybe, you brought that to the presentation, say, look, this is a cat. Okay, so if we were to differentiate, we would not be able to give presentations using 2D images because, oh, that's not physics. No, because you're making a representation of something else. I mean, I can show you this and say this is a rope, and but what do you see? You see 2D because you've got a screen that's pointing that out to you as a 2D object. Okay, it's the mind that said, well, I know that's 3D, partly because Bill is behind the rope, okay? But I can point to a picture of a rope and say, look, rope. Are you going to think that that's 2D and that's not acceptable in science or in physics because it's 2D, because it's just an image, it's a representation of a rope? So obviously, the word shape is just fine, even if in your mind it's 2D, which it ain't the world over. Everybody uses the word form, and it's the same thing as shape. Shape is just an English word that means form. Okay, I hope that's taken care of. And this person had another issue, and he said, material sphere form has the shape of a circle. A magnetic field has the shape of a circle. No, a magnetic field has no shape whatsoever. And let me prove it to you. Proof. Here's evidence. Okay? Authority. Okay, we go to the Physics Stack Exchange, a prominent site for so-called physics, mathematical physics actually. And what do they say? They say, look, all fields are really infinite. Okay? The magnetic field decreases with the square of the distance. Magnetic field, you know, field, decreases with the square of the distance. It never ends. You move away from a current that generates the field. The same goes for a static magnet, etc., and they put the little infinity sign there. So where does the field end? At infinity. It never ends. Okay? And how about the, in fact it says, the magnetic field in the same way as an electric dipole field will vanish where? At infinity. And how about the gravity field, gravitational field? Well, the same thing. Gravity has infinite range. The force of gravity decreases 1 over r squared, thus slow enough for it to be felt, etc., on the other side of the universe. So how big is the gravitational field? How big is a electric field? How big is a magnetic field? They are infinite, conceptually infinite. They stretch out forever. Okay, so this notion that you have that a field, any field, has shape, you forgot to factor the definition of the word field. All fields are infinite. And whatever is infinite has no shape, no form. Okay, because you cannot see the end of it. You cannot see the edges of it. Okay, so please point to a field that has shape. And whatever you point to, I'm going to put some more of those numbers there and show you that it extends forever in any direction that you wish to see it. It's just that you do not realize that your field extends forever. And so something that extends forever does not have shape. And until you understand that, well, you still haven't taken kindergarten classes in physics. Okay?